This is page 227 of our alternating series chapter section. All right. If a if a convergent alternating series satisfies that condition, which it needs to be converging, then the absolute value of the remainder Rn, so this is defining what Rn is, involved in approximating the sum S. So S is the actual sum, and Sn is the partial sum, the nth partial sum, is less than or equal to the first neglected term. Okay, that is a really complicated way of saying this thing. So the difference between the actual sum, so big S without a subscript is the actual sum, minus the sum you found, so let's say like S sub 5 where you found the fifth sum. In example 2 here, they're asking for the sixth term sum. So this is saying like you use 5 terms, where n is 5 terms to find the sum. That is equal to the absolute value of the difference between those two, right? The actual minus the approximation you're using equals, and this is called the remainder, right? This is called the remainder, and that remainder is less than or equal to the term you left off, right? The next term you could have used. So in this example here, the next term would be 1 over 7 factorial. So what this is saying is this will just be the sixth partial sum if you found it, okay? And this is off from the actual sum by a difference of 1 over 7 factorial or less, right? The error is this much or less. And that's what that theorem says. So the idea is you look at the next term. So how far is this off from the actual sum? The next term at the most. That's what this is saying. So let's find this. It says approximate the sum of the following series first term. So 1 factorial is 1. So it's 1 minus a half plus a sixth plus, let's check my signs. Minus, plus, minus. 4 times 6 is 24. Plus 5 times 24 is 120. Minus 6 times 120 is 720. Then let's put that in the calculator. So that's going to be, turn it on. Okay, so it's going to be 1 minus half plus 1/6 minus 1/24 plus 1/120 and minus 1/720. And I get 0.631944. 0.63194. Repeating. All right, now let's see. So this will be off by 1 over 7 factorial. So the error would be, what's 720 times 7? Right. That will be 1 divided by 5,040. So it's off by 0.0001,984. So this sum, which is S6, is off by this much at most. That's what this is saying. So this sum, this approximator, is off by this much at most. Okay, we don't know exactly how much is off, so you can't say, oh, just include that and that's the actual sum. No, because then it'll be off by the 1 over 8 factorial if you include that, right? Okay, so this is saying this is at most, that's the error. All right. So with this in mind, you can actually guess how far you need to go to get an error less than a specific value. So here, determine the number of terms required to approximate the sum of the given convergent series with an error of less than 0.01. Okay? All right, so then all you got to do is look at those terms, right? Look at those terms. So let's say I try n equals 2. If n equals 2, and remember, you're ignoring that negative business. So it's 1 over 2 squared. So that's 1/4. That's 0.25. So one term is not enough. Notice I'm saying one term when I use n equals 2. So let's go a little bit further. So let's say n equals 4. All right, so it'll be 1 over 4 squared, which is 1 over 16. And we can just put that in the calculator. 1 divided by 16, and I got 0.0625. That's 0.0625. All right, I want to be within 0.01. Well, that's still not enough, but it's not that bad. So let's try it. N equals 5. So that would be 1 over 25. All right, 5 squared is 25. 1 divided by 25. 0.04. I should know better. All right, so let's just jump ahead. Let's try n equals 8. So that's 1 over 64. 1 divided by 64. I'm still pretty 0.01565. So 0.1016. So I'm still too far away. So, oh my goodness, why didn't I think of that? N equals 10. 1 over 10 squared is 1/100th. That's what that is, 1/100th. I am so ashamed now. Okay, so 1/100th, that's 0.01. So you need at least 9 terms, right? It's the 10th term that's equal to that, so you need at least 9 terms. So to answer this one, you need 9 terms. Oh, that's embarrassing. Okay, what about this one? Okay, this would be less. All right, so this would be looking at 1 over 2 to the n over n factorial. And I'm going to just, right off the bat, just try n equals 5. Right? N equals 5. That'll be 1 over 2 to the 5th times 5 factorial. And I probably don't need that much. So let's put that in the calculator. I'm going to go ahead and put this in the fraction form. So it's 1 over 2 raised 5 and 5 factorial 5. And your calculator has factorial. You go to math, and it's under probability, and it's 4. So 5 factorial, press enter, and that is, oops, just press math to enter. That's 0.00. That's 0.000, right? It's 10 to the negative 4, 26. So I went too far. So 5 was too big from the get-go. So let's try 3. N equals 3. All right, you might be thinking, isn't there a better way to do this? Well, there are other ways to do this. Better, I'm not convinced they're better. Like, there's an analytic way to do this. You can actually set this equal to 0.01 and solve it. Now, I should have probably done that with the first one, because solving this equation, 1 over n squared equal 0.01, that's easy, right? Solving that equation is easy. But solving this equation equal to 0.01, okay? I don't know about you, but I don't have a whole lot of experience solving n factorial. So guessing check is not a bad idea. So I'm going to put that in the calculator. So it's 1 over 2 to the 3rd, 1 over 2 to the 3rd. And 3 factorial, that's 6. Put it in. And I get 1 over 48, which is math 2. Enter. 0.02. Oxabioi. 0.02. So I missed it by 1. Right? Or maybe 4 is not enough either. If I do n equals 4, that'll be 1 over 2 to the 4 times 4 factorial. That's 1 over 2 to the 4 is 16. 4 factorial was what? 24? 24. 16 times 24. So 1 divided by parentheses 16 times 24. Yeah, I got tired of doing the fraction. 0.0026. 0.0026. So what's the deal? All right. So 0.02 is too far, or not far enough. 0.002 is more than enough now, right? Okay, so that means I need to go as far as 3 terms, and I'll be as close as 0.01. Right? So I only need 3 terms. 3 terms needed. Remember, that's the first neglected term, right? That's the first neglected term. That's the first term that you don't use. So you go 1 before that, so it's 3 terms. Okay. Next one. What does it mean for something to have absolute convergence? Okay, so we've been looking at alternating series, right? We've been looking at alternating series, and these are, so remember the original series, this one, 1n, that's the harmonic series, and according to the P series test, this diverges, okay? But when you switch it to an alternating series, it suddenly converges. So this is a conditional convergence. Okay, this is considered a conditional convergence. It's because of that -1 to the n plus 1 that helps it converge, right? That's called a conditional convergence. But if it converges without the -1, like, right, if you took the absolute value of it, so it converges even though you got rid of the -1, then we say it converges absolutely, right? That means you can take the absolute value and it still converges, okay? So that's what absolute convergence means. If you have a series that it only converges because it's an alternating series, that will be a conditional convergence. But if you take the absolute value of that alternating series and it still converges, then it's absolutely convergence. Okay? So really, basically, if you take the absolute value of the terms of the sequence, and I'm including the -1 here, right? So this A sub n includes the -1. If you take the absolute value and it converges, then it's absolutely convergence. But if the regular one, the alternating series converges, but when you take the absolute value and it diverges, then we say it's conditionally convergent. Okay, that's what that is. All right. So let's look. Determine whether each of these series is convergent or divergent. Classify as absolutely or conditionally. Okay. Okay, so we got n factorial over 2 to the n. Ooh. I'm not convinced that converges at all. N factorial over 2 to the n. Well, let's just look at this for a minute. N factorial over 2 to the n. All right. We have not discussed much, but we did say factorial overpowers exponents. This doesn't converge at all. This is just plain divergence. Right? This is a divergent term. This fails the nth term test for divergence. Or, remember, alternating series, these terms have to go to 0. This does not go to 0. Okay, so let's say you had n equals 10. That'll be 10 times 9 times 8 times 7 times 6 times blah, 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 4, 3, 2. And 2 to the n means you got 10 2's. Right? You got 10 numbers up here, and 9 of them are bigger than 2. So the numerator is growing much faster. So the limit of this is infinity. So this doesn't converge at all. We say this is divergent. And I'm not using any of these tests, right? This is just divergence by the nth term test for divergence, right? Even if you put -1 on there, well, who cares about that, right? Because the terms aren't going to 0. Remember, that was one of the conditions for an alternating series test, that these terms have to go to 0. It's not going to 0. It's going to infinity. All right. Let's go to B. Okay, this one, right, if you get rid of the -1, it will not converge. This is conversion because it's an alternating series test. So what am I saying? So if I have this, that's taking the absolute value, right? That's taking the absolute value by a P series test, or P equals 1/2, this diverges. However, if you apply the -1 by the alternating series test, it converges. So this is a conditional convergence. All right. Rearrangement of a series. A long time ago, I asked you the question, if you add, is addition commutative, right? That means if you rearrange the order of the addition, can you get a different sum? Well, when there's a finite number of them, no. 1 plus 2 and 2 plus 1 are the same. But if you have an infinite number of them, changing the order actually changes it. Well, but this is not really an AP topic, so I'm only going to just mention it here. Okay, I'm not going to go into detail here. But that's it. All right.